Welcome back, Friendverts. Today, we're going to put together a KlackEnder. Hopefully. Let's get to it. Alright. Quick look at some of the parts that you're going to need if you're going to do this. And we're going to go about this in the incorrect method because I'm just like that. I do not have the official switch. But we're going to try this with what we got. So, of things you're going to need, just to get started, is you're going to need some 6mm by 3mm magnets. I believe it is 6 total. I've got a bunch here. They're cheap on Amazon. You're going to need some 3mm screws. And these actually vary in size. When we check the instructions, they actually give a range of sizes on some of them because it just kind of depends how it fits on your printer. I've got, I believe, a 12 and 2 10s. We'll try both, see what happens. We have the 4 printed parts that come directly from the GitHub. I've already gone ahead and put some T-nuts and M3s with washers on here. Unfortunately, I don't have any M5s that short, and I wasn't going to cut any, so this should work fine for what its job is. Here's the actual mount. And these are just in PETG, because this is not going on an enclosed Ender 3. And I did white because, well, that was what was sitting on the printer and I wanted to use it up. So, we need those 4 official parts, some screws, some that. I've got a couple pieces of heat shrink tubing, because we're going to have to cover some wires. I have an original end-stop cable. It says for a Z off of an Ender 3 because I don't want to make a full cable. It's probably going to be slightly short. I believe it is. So we just have some spare. This is, I believe, 5 conductor wire, and we'll just strip off 2 of them and we'll extend that. And then also, because I don't want to cut the end off of this cable, we're just going to take a JST plug and then make a short little dongle out of this to extend it over to this. So that way, if our actual probe goes bad, we could, actually wouldn't be this part, it'd be the mount part, we can just swap out the whole thing. The other pieces you're going to need is the switch. So to get that switch, I took apart one of the official, I believe it goes that direction, nope, goes that direction, end stop mounts that comes with an Ender 3. Since I've gone sensorless homing on a bunch of them, I know it's not the correct switch on here, but it actually fits the right size, and I figure if it lasts long enough for an Ender 3, we'll see how long it lasts. And I have several, so this gives me time to order one. So I did have to desolder it from this board. Of course, there's 2 screws. That's what these are for. It came out, hold the actual physical board on, and then there's 2 more, which we are going to reuse, which go through the switch and hold it to the actual PCB, while the other 2 hold the PCB to this piece of acrylic or plastic. It's actually plastic. That's odd. I swear some of mine other are acrylic. So I had to desolder that. So as you can see, I've already straightened out 2 of the legs. Here's the original switch. And all 3 were bented in 90 degrees. To get that off, I did have to desolder it, which if you have not done that, when it goes right, it goes right. When it goes wrong, it goes wrong. This one actually pretty easy. It's easy to work on. To do something like this, it is handy to have some helping hands. You're also going to need a little desolderer, and if you've never used one of these, basically you stick the soldering iron on one side of the pad, this on the other where you can get it, suck it loose. It takes about sometimes 1 time, sometimes 15, 20. Better one of these you can get, I highly recommend it. Other thing you're going to need, some diagonal cutters to cut off the center pin. Some other type of straight pliers for straightening out the legs. A soldering iron, ideally a good one with a good tip. Make all the difference in your work, I guarantee it. And then of course, a ton of flux. And I use this liberally on everything, and it just makes soldering and desoldering so much easier. It just really helps. So always a good investment. You can't ever use too much. You can always clean it off. Once you've got it desoldered, well, you can get rid of this guy. And this piece and the 2 screws. And I will just hold on to them. Actually put that screw up my other ones. I like to keep all these little parts in case I ever have to go back to stock. We can actually do that. Some other things, obviously going to need, I've got some JST plugs and pins just in case. Selection of heat shrink, which I believe this should be all we need, but you never know. And then of course, I have a T-nuts, 3, 4, and 5. And then a whole range of 3 millimeters and 5 millimeters and some washers. Every project these get used. Go ahead when you get into 3D printing and just go ahead and buy some M3s, one of these whole selections. This is, oh, it just says selection. It says on the inside. No, it does not. But this one says 6 millimeter, 8 millimeter, 10 millimeter, 12 millimeter, and 16 millimeters. And you'd be surprised how many of these and the different sizes you'll use when you go through, especially modifying a printer, because every person who's designed a part shows in different thickness. And it's only a handful of them where they actually think ahead to allow you to use the original bolts and screws. That's a big one for me. If I can get away with not having to go into this stuff, it's even better, but I've just had too many experiences. So I highly recommend when you get into, if you're going to modify printers, get a set of the M3s. If you're working on Enders, M4s, and some M5s, not a bad idea. And then a whole thing of T-nuts. Washers are a good idea as well, because you will use them. Same thing with the JSTs. Go ahead and get you a whole box of them. Do not get these crimpers because they absolutely suck. These are the DN28Bs. Nothing but problems. Buy the good crimpers. Don't get the cheap ones. You'll end up just... You're going to pay for it. It's either in your labor, your sanity, so you might as well just pay the extra $15, $20. Get the good tools. So yeah, so let's get to it. So I'm going to bring up the instructions. Possibly. See if I can get this to come up. Not the clicky probe, we want the KlackEnder probe. All right. Share this browser with you. I should have had that set up beforehand. Alright, there we go. I'm also gonna make that camera just a little easier to see. It's a little small. Put it up here. There we go. Got microphones working. There we go. Okay. Even though this camera is supposed to be way better, it sure looks way worse. Get this in a good shot. There we go. All right. So I am going to look at the instructions because I have not. Is it compatible? I hope it is. Click on the picture below to start. Yeah, the Omron D2F, I highly doubt this is one of those. Connectors, fasteners, M2 by 10, which is these little bitty ones, self-tapping, M3 by 10s, which is over here, M3 by 12 to 16, which is that one, M5 by 8, I believe that is for these two, but we've already replaced that, yep, with the 2 T-nuts. An M5 by 45 for the belt mod, and we are not to the belt mod on this printer yet. 6 6x3 magnets and a small zip tie. Oh, forgot the small zip tie. There we go. PETG or ABS. All right. So where is step 1? All right, let's start with stuff we can. I guess the mount. Right. So we need some wire. Oh no. Let's get rid of this piece since we don't need it. These 2 screws. So we are going to strip some wire, 10 to 15 millimeters. Insert it from the back into those 2 holes right there. Bend it over. I'm confused because then we insert the magnets, but the switch is already installed. Then we cut off the wire. Then we mount it. Ah, gotcha. Yeah, using the magnets to make sure you get the polarity right. Duh, duh, duh. Okay, should be easy enough. Just gonna cut about. I think we're gonna go long. We might use a shorter. I did have some shorter one of these in stock cables. If there's one of those old ones, it's a very short one, I might use that. And then we will just use a long piece of this cable. It's gonna save it, but let's just keep it short and sweet and simple. Get rid of this. We're going to peel off 2. I'm gonna go with blue and white. Honestly, I don't know what gauge cable this is. So, split the ends. Nice. Right. Make sure I get that in camera shot. That previous camera was way too far away. This one's way too close up. Go. Twist our wires around. It's also very color shifted. I would fix that, but the last time I tried to fix that and got it looking absolutely beautiful, it then quit working, and I've just wasted like an hour trying to get that camera to come back. So it should not matter polarity on this switch. Just gonna stick these through. There we go. Get that insulation all the way down in there. Pull the wires over. Go. Whoop. We're going to use the needle nose. We're going to use the needle nose, just pull that wire all the way taut. Oh, there we go. Yeah, it's much more secure. Hold that over for now. All right, let's get 2 magnets. Does it matter if one is reversed polarity? Okay, we were supposed to pro block first. Okay, well, too late now. Let's click on the pro block. See if they want us to reverse one of the magnets. Okay, so one does get reversed, right? What we'll do is we will take a whole stack here. Should do this in camera shot because I can't see my camera. Push one in. Maybe. We'll put it in and then we will determine its polarity. There it goes. There it goes. Let's push it down. Go. We have the first one in. That went pretty well. Let's make sure we... It wants to match up, so then we take it and flip it 180. So the matching side is now facing up. Let's confirm that. Yep. This is giving us two different polarities on the magnets. I assume that just helps keep it aligned better. Got it most of the way in. Lord, that camera's horrible. All right, push down. Okay. Oh, the one thing I forgot is they said we would need a razor blade to do this. I have a very dull one with a broken tip. So let's see if this works. Go. That does work pretty well. So magnet, taking my blade, give it. There we go. Yeah, that came out very nice and clean. Yep, can't even feel them. Let's throw these pieces in the garbage. Or just onto the floor, so next time we have no shoes on, we can get a million small pieces of wire right in our toes. Okay. First part of that was easy enough. Let's go back over to the instructions. Back to what we were working on. Those two through, clean it off. Also the magnet, we did that. We did that. Now you can place a zip tie to fix them in place. Right, let's do the zip tie. Oh, excuse me. Right. It's fine. There's the zip tie hole. Wires off to one side here. Seems a little strange. Would have figured it would have gone like straight up the side, but apparently not. Go. Let's clean it up. Put that away. Right. Before we go on the next step, I want to go ahead and solder these to my 3-pin terminal, because these cables are all 3-pin on one side, 2 on the other. 2-pin goes to the actual main board, 3-pin goes to the end stop. We're going to use the 3-pin connector, and then we're just going to solder to the 2 outside pins. We're going to get the soldering iron turned on. And this here is what we're going to use all the heat shrink for. So before we do anything, we're going to put our heat shrink tubing on. This is why I like several pieces. There's a large piece to shrink down on this. Seems a little long. Go about in there. Save our little spare piece. All right, stick these 2 on. This one on. take some flux and flux these wires. Also going to do the pins. Just makes everything so much quicker and easier. Get rid of the flux. Helping hands, and to help hold this and dissipate some of the heat, because if you've ever tried to do this, these pins love to get hot and then just melt the plastic right around them. So we will take the cable, and we're gonna stick it into the plug, and that will keep those pins straight and also allow some of that heat to dissipate through the metal connectors and the wire down, so like a big heat break. Help my hands there. Everything's sticking to each other. Okay. So over here, we have the flux on them. We're going to tin everything first. Soldering iron's up to temp. Another reason to get a really good soldering iron. It will save you so much time. All right, so we're just going to hit it. There we go. Oh, sorry about that. Go. Now we should just be able to go directly to them. It's not going to matter on polarity on these guys because these are unpowered and these are just taking signal to ground, so there's no active power. Go. Well, let me show you how not to solder. Go. And go. That heat shrink on. Ugh. And the second one shrank too much. That's okay. I have a solution for that. This is part of the reason I do that. We will just shrink those down, even though one of the pins isn't covered. So then we will take our second and encompass both of them. I should have gone one bigger size. There we go. So now I have our wiring harness connected all the way through our dock. Get rid of this extra cable. We're going to also throw the meter on this. Get rid of the helping hands. That soldering iron. You wouldn't believe 2/3 of making stuff and projects is just putting stuff back. It's so old. So we're going to test everything real quick. That one works. Oop. Okay, I'll go to the opposite pin. Just make, yep, we got no shorts. That's good. So we have continuity all the way through. Should be the only time we need the meter. Now we can go on to the next step, or the first step. So there was the probe mount. Yes, that was probe mount. Keep that for installation instructions. All right, let's go to the switch. So it looks like we just slide the switch through after we cut off the first leg. And take out the little lever. I'm not sure what those two little holes are for. So the direction of the switch is kind of important. So you just slide it in there and then slide the magnets in. I get the feeling we're going to have some trouble because there's probably just a bit of solder left on those pins. I did not take the time to put some copper desoldering braid on there, get all the little pieces out. So basically we're putting the switch in, the 2 screws to hold it, then we put a 3 magnets in, and that's it. All right, so let's do the first part. Let's cut the switch. Got this 3rd leg. There you go. Right. Let's take our dock, switch over so I can make sure y'all can see, because I'm running on one monitor. So they did say it looked like it went. I'm looking at the eyes. Oh, let's do the other part first. Take this off. Move it up above the red button. Bend it in. And it falls right out. That usually happens when you don't want it to happen. Okay. So that is the first part. So it appears this, yep, it is normally closed, and this is going to open it. So it's going to go from low to high. We can ignore this part right here because we're not plugging into a 3-pin end stop. We're plugging into a 2-pin. Okay, so let's look. We are looking at the face. We want the button away, and it, wow, fit right in. Look at that. That was way easier than I expected. I did clean out these holes earlier. Okay, so let's put the 2 screws in. These are the 2 screws from the original install. Precision screwdriver. That is going in nice and easy. Oh yeah, you can feel it grab right in. That is very nice. Oh, that's what the other 2 holes are for. Those are for the screws to poke through. Very smart, very smart. That one doesn't seem to be grabbing as hard, but it is definitely in there. I don't expect that to come out. Any clickies? Okay. So now, we need to put the magnets in the top, I believe. Go back to the instructions. So, magnets in the top. And because we did this out of order, we need to confirm we get the magnets aligned correctly. Thank you, YouTube. Right. So, Which way does this face? It faces to the back, like that. Just a little screw hole. It's going to go like this. This is going to mount out like that. So we need to make sure our magnets match up. Yep. First. Okay, here we go. We have our 2 matching magnets. We're going to go just like this in there. So let's take the first one. This. Oh boy, I almost stabbed myself. No, no. Okay. Ooh. That is a little tough. So when that keeps happening, so what we're going to do is we're going to take that, we're going to stick it on the end there. Already. So want to bend those legs over. Whoop. Can't push down like that. That's going to smash the switch. Dar. Okay. We're going to cheat a little. I'm getting tools. All right, this should do us. Double check these. I guess the legs on mine are longer than normal. Maybe I need to cut them down. There's a clear slot. What I'm going to do, 2 things. So basically I got some channel locks. I'm going to take a flat precision screwdriver. I'm just going to push these down in the little slots, make this a little easier. Alright. Definitely went into the slot a little more. So make sure we keep our front. There's our front. I'm waiting for this magnet to jump right off onto my phone. Now that we have it in place, I'm going to take channel locks. Maybe. That way. There we go. Now it's stuck in the correct orientation. As long as we don't hit the switch, be okay. Which I am hitting. I'm actually going to flip this upside down. Alright, move the magnet to the longer end. That's giving me much better perch, and I'm not on the actual physical switch. Ugh, so close. They fooled me. The other side was so easy. I thought the wire was going to be the hard part. Wow. Lordy. Okay. Ah, it was in. I swear it was in. Place my finger on one side. And there's somebody on my ceiling. Or on my roof. Ah, no! Wow. I am really surprised this is being this difficult with as easy as one was. Oh, oh. Okay. I think we're there. Yes, we're there. Wow. And it's rising up. Interesting. I think what we're gonna do is cut this one off first. Probably missed that instructions and that just flew over right where my feet are gonna be. Yeah, it sure does leave a little bit of a... Well, at least we got it the right direction. Let's try and get the second one in. Or with cleaning these up. Whoa. Ah! Okay. Ah. Oh, we lost the magnet. I have no clue where this camera's looking. Let's try that. Just proceeded and slowly pushing the other magnet in. Ah, Lordy. Go. Wow. That was really tough. Oh, no. Stay in there. And it's still just trying to shoot right out. That is no fair. I don't remember mod, but any of these issues. Okay, there's one in all the way. I squeeze down. Let's get this one in all the way. One really likes to keep floating up. Not sure if that's going to affect it. Yeah, you can see it. It's not sitting level. It should still work, but that's a little concerning. Wonder why that magnet is trying to float out. Okay, well, much harder than we anticipated. Put our tools back. Okay, let's go on to the next part. Yep, I should have cut them off first. Probably would have made that easier. I bet it said up here. No, it does not say. So apparently those come with very much shorter pins. Okay. So now we need to put a magnet in the side, I believe, which I'm confused here as to why they show it already in. Third magnet belongs in the side. Okay. Well, there we go. That one went in super easy. Wow. Okay, I like that. So that is all for the actual cookie probe and the mount. Over here to this one. And it just says some screws and T-nuts. And the left channel of the right. That is going to be this piece. Okay, that makes sense. And it needs to be about the height of the actual heat bed. That's it. Okay, I think we can remember that. This one we're going to need a screw and a magnet. So that is our last magnet and the one screw. Thought there were two screws for some reason. No, this is where he talks about the different length screw and possibly backing it out. It says he's used between a M3 22mm. Okay. I think it's about time for the printer. Move some stuff out of here. Knock all that down in a little bit. Here's our Ender 3 Pro. What did you put your part? Boy, viewing angle in this camera sucks. Alright, so this guy, T-nuts, is going to come over here. Right about in there, apparently. Right about bed height. Oh, it's already caught itself. It's the right Allen key. Okay. There's the interesting part. It looks like I said we could remember that part, but it needs to be much lower, and that is going to be very hard to get into. So it does need to be right about bed height. So we need to come down. Alright, barely back those off. Showed it just barely above. I guess that's just to make sure you don't catch anything. There's the top one. Let's see if we can get into this bottom one. Alright, there's some something to be aware of. Make sure you do have some small Allen wrenches, because I could not get my good set in there. I would end up having to take the whole display off. Okay. Close that. Keep that one for putting it on. That's what we just closed. So we need to get a magnet on this guy and a screw and get it mounted. Okay. We're going to take this guy. We're going to use this 10. Straight Allen. Nope. That is correct. Stick it in the back hole. Does not like it in the back hole. Take it. There we go. And this just kind of self-taps itself through there. Feels like he designed these holes absolutely perfect. I don't believe you have to use this socket head. You could have used a button head or really any type of bolt in here. But it looks like it was designed for the socket. Head bolt, hole size seems to fit. Just have some, there we go. Our screw in the back hole. So now we need to figure out our side magnet to make sure it matches up. Which has some screw attached to it now. So like that. So we want to take this guy. Since he is going to be like this. That's what that screw is for, is to help catch it. That's why there's that slot back there. That's why it gives you such a length. You could use a much longer screw. So I'm gonna take that, make sure it stays going the right direction. Put it in the hole. Okay. That wasn't too bad. We'll use a screw, stick it down in there. There we go. Didn't need those other screws. So there's our magnet down in there and our one screw hole. So now we can go back to the printer. We're going to take our crescent wrench. And since these are lock nuts, on there so it doesn't spin. It's going to be the last one of these I touch. You is you. All right. Best not to scratch my paint job up. Go. Y'all can see that. Sorry about that. I'm gonna push this screw back slightly. That wasn't slightly. Watch it. Out. Slide this guy on. Place. Of course, you fall out so easy, but going in, you're going to be tough. Just barely catching on that plastic. Get our nut started. Get my elbow out of your way. Sorry, y'all can't see. Go. Still spins. Yep. Bound up or anything. That should be done with that. With our pliers. All right. Now we get to go to the actual mount. Oh yes, we did need one more screw. That was for the mount. It's not lift up by the bed. That would be bad. Okay. Luckily this is a Pro with a belt tensioner. Makes that pretty easy. We lose all the parts. I'm kind of confused as I have two Pros, but one came with belt tensioners and one didn't. I don't. Were these an add-on afterwards? I don't know. I got into Creality's late, so do not know. All right, we're gonna go back to the instructions. There is probe dock with the screw with the magnet. It is installed. So we will have to adjust that at some point. So we need to mount it. So we are going to not pull off that belt because that's the wrong one. So we get it back on in there. I want this side off. Belt is out of the way. Here. Let's bring this up a bit so we can see what we're doing. That screwed up my alignment on that side. We'll have to definitely tighten that back up later. Okay, easier. So with this guy, should just slide right under. Yep, facing backwards. And the belt just goes right back on and a screw goes on. Let's try this. Go. Facing backwards. There we go. Went right into place. Belt back. Some tension on it. There we go. Dock is mounted. Let's throw the probe on here, see what happens. Right into place. You can still see those. It's trying to come out. I'm probably going to have to put a little dab of super glue in there. What's going to happen? There it is. So it comes back. Catch on the screw, but of course we were seeing. Oh, got that slightly angled. Go. That is hitting. I'll back the screw out a bit. Right above me. There we go. Slides in. Goes down. behind the dock. Slide sideways. There it is. Comes right out. Picks right up. There we go. Like the kind of, I see why they call it the KlackEnder, because it clacks. Okay, there we go. Yep. That is probably the easiest bed leveling sensor install I've ever done. Definitely way easier than a BL Touch or one of the clones. Easier than even inductive or capacitive with having to move it up and down and get the height adjustment right. I don't know if you guys remember that. You're like, I've spent days just trying to calibrate those sensors. I'm so glad they're gone. All right. This has clearance. Probably end up doing zip tying in that wire right over to the 2 fan wires so it doesn't rub on anything. This goes back and back. And for now, to be sure this is working all the way and reliable, we're not going to run it through the cable sleeve. We're just going to tag it on there. Then once we're sure this is good to go, we will throw our zip tie across the room. No, we will pull that cable sheathing back and run this through. I probably shouldn't even be zip tying it, but I want to keep it out of the way. There's one concern. I wish there was a little more clearance. Is there some kind of shield to make sure it doesn't rub on these actual 2020. Bring that down. And the thing we forgot to do is put the last screw in. Let's do that before we go any further. Not quite sure how this is supposed to secure it, but it says to do it. Eeny, meeny, miny. Not you. Not you. Last one I touch. Not you. Too small, too big. How did you end up on the very bottom? Now going to put this last screw into the side of the mount, right next to the wires. It's supposed to hold it in place. Wow, this is probably gonna be the hardest part of this. Real easy spot to get your hand in on that. There we go. Yeah, it looks like there's the secret. Bring it all the way over. It's the only way I would have get this Allen wrench in the long ways. We would not been doing a million turns of the short side. We would go find a bit, stick it in our bit driver. Feels like a very long screw, but it is the size screw they said to use, so I'm using it. Not quite sure how this secures it in there. I don't see the slot contacting the screw inside. Maybe it deforms it just enough to put some pressure on it. That's what I'm thinking. Oh boy, now it's getting tight. Yeah, we're getting the bits. This is when we find out this is the one I have broken. It's definitely not Torx. Nope, not you. It's gotta be you. There we go. Oh yeah, it's much easier. It's what we should have done from the get-go. Yep. I'm just pulling that wire south of the screw. Just want to make sure it's not caught between the screw head and the 2020 of the X-frame. Almost there. Go. That is in. My bit back. So everything is still working. Like that. I've done that because I need one more to get to the bottom. I know this is ugly. It is temporary. So ugly. At least the blue and white wire kind of matches. I'll just go for that for now. Just so we're sure this is good and reliable. The nice thing about having that spare end stop is I did not have to remove the original one. So if this does not work, I can just go back to the one that's still here. We're just going to leave it. Oh, now we need to get it into the bottom, hopefully without smashing ourselves with a spool. Drop that off. I know I was lazy. Go. I forgot the one on top. Take out our 3 screws. See what I'm doing here. Actually, now at this point, I think we can... There we go. Go back to our standard camera. Smart people are asking why I am not using that nut driver for all of these. I do have the bit, but they fall out. It's not the proper handle for it. Taking the last screw out the top. As always, there's 2 long and 2 short. Oh no, 3 shorts. 3 shorts, 1 long. And one of the others, 2 longs. Okay. Go. Let's bring this back down in here. We're going to take our spare in-stop cable. We have a ton of spare. Or do we have a ton? We want to find the Z in-stop, which should be one that comes through the side. And it is clearly marked X, Y, and Z. Disconnect that. We're going to go ahead and leave it in there. Everything exactly how it was, just so we don't have to worry about problems. We can go right back. Plug that in. Get into our tape here, give a little protection. Luckily there is no voltage going through this wire if it did ground on the frame, but it could cause some real problems. And I'm sure y'all can probably see I've already been in here and cleaned this up a little bit. Alright, so this guy gets to go right into there. There we go. Got plenty of length. Close this back up. Catch any cables. Make sure our fan isn't getting caught in anything. Ah! Stay, stay, stay! Go. Been prepared. Don't fall, don't fall, don't fall. Okay, that one started. Second short one. Get it started. Long one goes back in here into the 4040. Squished. It feels fine. Oh, I'm really confused. This camera is supposed to be a decent camera. It's been more stable, but man, it looks horrible. And I have gone through the settings too. Alright, so there's the 3 on the bottom. And stop wire out of the way. Let's get our last one in. So let's get our filament re-rolled and back on here. Here we go. Weird. Apparently, done with all our tools. Did not need the second bolt. Let's go ahead and try and get this thing to start up. See what happens. Hopefully I do have enough length to make this do everything. Data. Start power. Just enough power. Let's kick it on. There's no magic smoke, so that's a good sign, although I'm stepping back just in case. It doesn't work! Oh wait, it's clipperized. Do we not reboot? There we go. Okay. Printer is online. Shows it's working. Now we just need to get the clipper actual config that needs to go in there. Is it not on here? Okay, we've got it built. go with Clipper Z calibration. Go ahead and open that just in case. Discord server, STLs. I have all of that. Oh, I bet I have it on the desktop. No. Do not. Okay. Kevin, aka Sam, KlackEnder probe. Firmware. KlackEnder Rev 2 config. Let's go over to raw. Okay. Add this to my printer config. Change your Z in-stop pin from in-stop pin whatever to in-stop pin probe virtual Z. -8. Okay, let's copy this over to our folder. New file. Let's call it KlackEnder.cfg. Ah, we get a menu. Okay, did not see that. This is much easier to read now with the. So we have auto bed mesh, G29, accuracy, Z tilt adjustment, which can't do. Probe out, probe in. Homing override. Fade target, don't need to worry about that now. Okay, so there is the probe setting. Need to confirm pin out. Ah, till we break everything. All right. So we have this in KlackEnder.cfg. Just go save and close, come back up here into our printer config. We need to add that in there. Just add it here at the end. So here's why I really like splitting up the config file. All right, KlackEnder.cfg. Okay. That should, since we don't have a probe file, cover that. This config will set the probe as your Z in stop. This makes the initial setup a bit more tricky than with the Rev 1. This printer will set you to bed position as Z0 because it probes on that. You have to roughly position the probe retainer for the first step before you can set the final position. The top exclamation of the arm is be roughly 1 millimeter above the bed. Oh, we need to tighten our belt back up. There we go. Now it still works. millimeters on it? Yes, it does. Tell. Where's my other one? There we go. That's the one we're looking for. Whoop, other side. We are roughly 3.5 to 4 above the bed. Get right down in here. That's a little easier. Like right about 3. Let's just drop it down a hair. Lordy. Well, at least if I do this on my other ender, let's use the screen. Well, it does. It's just using clipper screen, but it doesn't use the stock screen. I won't have to go through this. Go. Loose here. I feel like just enough. Oh no. It's very close. Roughly 1 millimeter. Back up. Go. Nice and tight. Here. Okay. Find the perfect position for the probe retainer. You have to home the Z-axis. After this, the probe will be at the new Z0 position. Place the probe retainer close to the block so there's a small gap between them. You're using this probe as your Z end stop. This means that the position Z0 will also affected by your Z offset. Keep that in mind when positioning the probe retainer. Set the Y min position. Okay. So I have all this copied. So let's go back over to the one that's pretty. KlackEnder. So there's our probe config. Need to change this pin. Oh, no. This is... Uh-oh. Why'd we lose the screen? That's strange. Creality 4.2.2. Board pin out. Just go straight to images. That doesn't look right. Let's check. Wow, why is this board always the hardest to find the pinouts for? Yeah, it's a maker-based Robin, not even close. Oh, that's nice, but you're not telling me the physical pinout. Okay, let's go over here, save and close. Let's go to config examples. Let's find a Creality. Editor 3 Pro. Let's see. It does not look like it's using TMC, so this looks like the correct board. Alright, so where is Z and stop? I don't see one listed. Oh. Hold on, I'm being silly. Because we haven't changed this. Config. Enter 3. There we go. Under motors. It's up in PA7. And for Y position, we needed that -8. This one here. Is that for Y? Set the Y min position. -8. Position underscore min -8. Just copy that. There we go. -8. And once again, in stop pin is PA7. Okay. Comment this out. And actually come over here and grab this virtual in stop pin. Whoop, to this one. Right, so that should now be using a virtual and stop pin. We can save and close. Yes. Now we can go into the KlackEnder, and this pin needs to be the one that is changed. That's not what we wanted. Don't close. Don't save. Motors. Go ahead and copy all of this. It's back out of there. Oh, I made this tough. PA7. That. Leave these comments for now. I'm assuming all of this stuff is correct. Here's a bed mesh. Okay, that sounds right. Let's save and restart. See what happens. Ah, there's worse. Screen quit working. Cable fell out. KlackEnder.cfg, line 189. Okay. What is wrong with line 189? Menu type. That looks nothing like what it said the error was. Save and restart, see what happens. Did not see that. Oh, it's hidden at the very end. That's what's going on. Well, apparently copying the raw didn't avoid that. It's the first time I've had that issue with Clipper. Right, save and restart, see what happens. Line 188. No bed mesh, it's the last thing listed there. This is so very strange. See, we can try that again. No. Ooh. Is it that right there? Let's try that. I don't know what that does. I haven't played enough with menus, we'll find out. Aha, okay, so that helped. Option position in stop is not valid in stepper Z. Okay. In stop pin probe virtual Z. That sure seems right. To in stop colon probe colon Control C. Maybe we need space. Okay. Ah, wait a minute. Let's try that. Position in stop. Oh. Back. Position in stop is not valid in section. Okay. Ah, okay. It's in there twice. I see what's going on. I'll have to definitely clean up this config file. Let's see what happens now. No! Oh, well, this is different. Let's do a full restart. Let's power cycle the printer. So we did accidentally disconnect the screen. That might have flipped it out a bit. Right. Firmware restart. Tilt Z position needs exactly 1 item. Tilt Z. Okay. We cannot do a tilt Z, so we should be able to take that out. Z tilt. A little confused that's in there. Considering KlackEnder is designed for an Ender 3, which is a single Z-rod. Hey, look at that. We are connected. Okay. Let's try and home, see what happens. Home X. Okay, let's try Y. Move out of range. Okay. Let's try homing Z. Okay. Let's do this. Let's go down to machine. Check our end stops. Z is open. The other two are triggered. I'm going to try pressing it. Refresh. And triggered. And probe triggered. Letting go. Okay. Pressing again. So it should work. So Y is movement out of range. $245.10, $245.10. Yes, that does not seem right. That should be in KlackEnder. Probably. Where is our Z safe homing? Do we not have Z-Safe homing? Well, that is kind of strange. Let's check one of the other printers. It does have a probe. Bed mesh, BL touch, control print, X and Y offset. Shouldn't have to touch that. Z-Safe homing. Look over here, just confirm. It's not there in the probe, the bed mesh. Homing override. No. No option for Z-Safe homing. That's kind of strange. Okay, we're just gonna stick it here at the top. See what happens. Homing override and Z-safe homing cannot be used simultaneously. Okay, that explains that. Oh. Alright, so how does this override work? Move up to 10, home X, home Y, probe out, X117, F3000, and then G28 on the Z. So home is the Z, and then it puts the probe back up. Okay, so why are we out of range? What is our bed mesh max? If that is our X, that does not seem correct. Did me no good. Oh, we're so close. What are we missing? Stepper Z needs a negative as well. Position min and position in stop. Okay. I will do it. Copy this. Save and close. Go over to motors. Paste it down here so we can't lose it. Stepper Z. In stop pin. Probe virtual Z. Position min. -8. Seems weird it is that way on Z and Y. Alright, so Y we have position min -8. Position in stop -8 as well. Alright, delete that out of there. Save and restart. Oh, should have had some coffee. Hey, okay. Closer, maybe. Let's see what happens. Home all. Move out of range. (245, -8, and 10. So why is X trying to be sent to 245? What is in that? Homing override. Where's I think it's at now? I think 0's at 8. Let's see what 235 gets us. Ah, I know what's going on. I know exactly what's going on. I think. Okay, that is going to be in... Not in steppers, because we don't have any good steppers yet. Motors. Max distance. Let's try 245. Alright. That's home. Okay, that's different. So our max X size was too short, which is weird. I copied that from the example config. Please work, please work, please work. Ooh. Wow, you don't even hear it click. Let's see what happens. Close. Oh, no, it worked. Oh, wow. It worked. Let's try that again. We're gonna home all. Definitely need to fix that one magnet with some little bit of super glue. Switch does hit and trigger first, so. I do need to pull this guy up just barely. Just barely. That is awesome. Okay, let's see if we can do a bed mesh. Alright, let's calibrate. Default. See what happens. Fail. Probe triggered prior to movement. How could it do that? I do like it goes all the way back to 0. I guess that's the clack. I do like the way that comes out. Alright, so that works. Let's see what happens if we just try to print something. See how off our Z is. We'll just get a couple layers if it will actually stick. And then we shall try to figure out this bed mesh. That is quite nice, I have to say. For the cost and the few parts you need, you're literally talking 1, 2, 3, 4 screws, 6 magnets, and the 1 switch. You're looking right about the investment for a knockoff BL Touch. Which at this point I don't recommend. They're just inaccurate. I've had so many problems. I've had just nothing but problems with them. They were a great invention, but path of least resistance, I have to say this so far is working really nice. Okay, heat bed's almost up to 50. webcam gonna fall off again. Go. Although possibly that one magnet sticking out is affecting the Z offset. We'll find out. So tempted to tap it with a hammer. To say this is probably the hardest part of this whole thing, is getting these magnets exactly the same. And I'm sure this would have been easier if I hadn't tried to desolder the switch. Who even choose a model that's, we'll find out. This is going to 215. Yeah, set for PLA. Yeah, okay. Wasn't sure what that calibration cube was for. I was just assuming that was the last thing I printed on this guy with this filament. I definitely think the instructions should call for just a dab, just a bit of a dab of super glue. One thing nice about this is you can actually play with it. Yeah, because that is angled quite a bit. Of course, my bracket is angled quite a bit. Yeah, that's definitely better. Yeah, these are definitely going to need just a bit of super glue, and not to get filament all over the magnet. Yeah, that time I heard it click. So that makes sense why it's the KlackEnder. Clack is a modification of the clicky. That's a little scary. Yeah, nozzle's you know, like 8 millimeters high. Let's cancel this print. Open the X so we can get this filament off. Okay, I swore I just clicked X, but it is homing everything. Yeah, that little gate needs to come up just a hair. That's why it's getting twisted. Okay. So, how do we do this Z offset? Okay, it's kind of odd. Really don't feel like I need another system service just to calibrate my Z offset. Right. Let's go to KlackEnder. Ah, measure per your specific setup. Okay. Let's say 4. Let's see what happens. I want to go turn that AC off because then you cannot hear me. Okay. It shows us currently at 10, which looks about right. Let's go to 110. Y is a little behind, okay. Maybe that -8 is right. Let's go down one at a time. Now we'll switch over to the points. Gonna take this little overture. Woo! Wow, right there at 1. It feels like a 0.2 there on that. So let's try. We're just going to put our Z offset to 4.90. Let's see what happens. I have never done that the manual method. This doesn't work. We will jump right over into the Z calibrate. It is something I feel would get more people using Clipper and mainsail or fluid. The fact that as soon as you install it, you really don't have all the macros you need. Like a Z calibrate should be right there on the main page as soon as you start up, because it's going to be one of the first things you do. Okay. Let's go to 110. 110. Go to 1 millimeter. That is on the ground. Oh yeah. So we need to come down, it looks like. Ender. Actually, here, let's just do this. Let's do this the right way. Instead of all this guessing. everything. Get rid of this one. Okay, I don't need to calibrate. Z-probe offset, that's what I need. Probe calibrate. It's exactly what I thought it was. Probe triggered prior to movement. How is that possible? Triggered. How's that possible? There's nothing here. Okay. Let's do this. A little bigger. Back over here. Refresh. Those are open. How are these still triggered? It's been working absolutely fine. Is it... Do I need to invert the probe logic? Okay. Okay. All right. So we need to invert our pin logic. Oh, lordy. I know it's an exclamation point. Come on. Invert finds us something. Not what we're looking for. That's it. Okay. Let's try that. Okay, that didn't make a difference. Will we error out? Oh, did not error out. Okay, no, yeah. Ah, comes after it. Okay, open. Open. Now what do we get? Triggered. Opened. Okay, so that is not the solution. Let's come back into here. Take Take that out, restart, see what we got. Well, no error. Triggered. Open. Okay. That is not it. Let's just try PA7, see what happens. I find it very odd. I'd have to invert the logic or a switch that was just moved from here to here. Open. Okay, that's what we're looking for. Triggered. Okay, let's take it off. But with it off, it's still triggered. And we get it back on, and it's open. Interesting. Okay, that triggers. It's back open. Take it off. Shows triggered. Let's test something. I'm gonna see if this is normal closed, normally open switch. Looks like it's normally closed. Yep. And it opens up when we hit the switch. So, what is going on? Open. All right, so that is obviously not the solution. It looks like need to pull up. So the logic isn't inverted. Definitely needs a pull up. Machine. Let's see what happens now. Everything is open. I close it. It's triggered. Okay. Let go. It's open. Let's pull it off. Triggered. I should have watched Modbot's videos, huh? Why didn't you warn me about this, Modbot? Should not need to reverse the wires. It's a two-wire circuit. Yeah, it makes no difference. Okay, well, sometime later, many moons late. No, it has not been many moons. It has been one moon. And unfortunately, I left my streaming system paused. One of my cameras has died without me rebooting, so we're just continuing where we are. This video did not go like I planned. It's definitely not like several of the videos I've watched online. So, quick recap, even though I know it was just a second ago for you. It was a day for me, so I'm going to try to remember. First problem we had, after getting the whole clicky probe on there, we'll explain this in a second. Regular Z-homing worked flawlessly. But when I'd go to do a bed mesh, two things that I found out. first is, which I didn't see this anywhere, it was probably in the GitHub in the documentation, but I just did not see it. So if we come, say normally you're coming here, do your height map, you home and you calibrate, you're going to get an error. The reason you're going to get an error is because at the time that that's happening, this guy is not on the hot end. And this is a normally closed circuit. So it means it's completely looping through the signal, grounding out at this point. And then when you pop it, when you click it, it's opening the circuit. So interrupting the circuit. So when this is not on the hot end, it is going to show that your hot end is triggered. So as soon as I would go to hit calibrate, it would do, oh, the homing would work fine. Go to calibrate, it would come up and move out and then be like, ZN stop triggered prematurely. So that was confusing. But I fixed it. Actually, I didn't fix it. It was already there. Part of the macros that you copy over, go back to my dashboard here. So when you want to do your height map, you are not going to come here. You're going to go to your macros, and there is an auto bed mesh right there. So actually, we will run through this real quick. So I'll show you the errors. I don't know why I'm just explaining it. We can see it. It takes a bit getting used to. We all have been trained to the sound of what our printers sound like as they're warming up, getting started, and that clack. Oh, for the first 12 hours of running through this, instantly panic of something's hitting, hot end's catching, something's breaking. Stand up, turn around, be like, oh no, never mind. And that one too. Okay, so it did the home perfectly. Now let's try and do the calibrate. Let's call it default. And boom. Probe triggered prior to movement. So I looked and I looked. I said, is this switch, that came off the stock Z? Is that? Is this a normally open switch? It needs to be normally closed. Compared it to the official one on the GitHub. They want it normally closed. This is a normally closed. Put it on the meter, tested it both ways. I mean, you can going off the center pin, but on these two ends, it's normally closed. So it was not the switch. So that threw me around and around. I tried pull-ups, pull-downs, inverting the logic on the pin, exclamation point, caret, or tilde, all the combinations. And then I figured it out, because I'm a moron. So, we're going to home again, just to make sure we're past that last error. Basically, I wasted about 5 hours of searching and changing my config over and over for no reason. Okay, we've homed. Now it's gonna dock the KlackEnder. Okay. Now we come down to bed mesh or auto bed mesh. Click that. And there we go. So I have not tested yet with any of my other sliced files. Sorry, I had to think there. If you have included to do a bed mesh calibrate before every print, I believe that's going to throw an error every time. So it's going to have to be replaced in your slicing software. Either, I use Cura, but with this auto bed mesh instead of the regular bed mesh G-code macro. So that way it will trigger this one, which actually grabs the KlackEnder ZN stop and then runs through this. These are 90% default settings. I did not adjust the speed or locations, number of probe points, which was quite impressive. Did have one more problem. Once we get through this, I'll show y'all. Well, two more problems, but one related to this. When we would get here, it would probe any of these along this edge 5-6 times, while it's just doing 2 on the rest. And while getting down and looking at it, you know, it's a single lead screw on the Z-axis. We all know the Ender 3 can get a little bit of droop on this side. It was drooping a lot. And that's my bad. I bought this printer off of a guy. I put a new hot in it. Kinda tweaked it because it was a little tweaked out when I got it. Mainly frame stuff, over-adjusted, under-adjusted. Tried it, and then it's kind of just been sitting on the shelf for months until I just got it clipperized and put these silicone mounts on. So that would trigger an error as well. It would try and get down there, and then it would just come back. I don't remember what the specific error was. I believe it was minimum height or something like that. So I was like, okay, we need to tighten up the eccentric nut. No, that was not the solution. No amount of tightening this eccentric nut would get both of these wheels touching. One would touch and one would freely spin, and then it would be opposite over here. And I was like, well, that is weird. So I spent hours loosening both of these as loose as they could go, then trying to get this as even as possible, and I could not get it. I have never had that much trouble just trying to get the slack out of one side. And as you can see right there, to me, that's acceptable. It was sagging down almost 2 millimeters. So the probe was actually barely coming off, and it was just too close. So I made one change. Let's come over here. I did Google that, and that came back to someone else had that problem. And it was not sample. Oh, horizontal move Z. I do not remember what the default was. I think it was like 5. And I changed that to 10. So this does come up 10 millimeters instead of 5, which gave it enough clearance. I've actually run into that with like BL Touch with that probe sticking out, things like that. So that resolved that. Then I had another problem, which was as soon as it would start the bed mesh, after I'm like, okay, we're here, it would shoot out, it would go to the first point right over here, and then would throw an error. And thank goodness for Google, somebody else going through this, and what it was, it's not in those macros. I should have done my homework. I'm sorry, this video is taking way too long. Override. You can see there's this probe out and probe ends. Check distance. No. Oh boy. I might be incorrect. No, it was not in this one. I can save and close. I don't know what I changed. I don't believe. Something important we had to throw in here was position min for Z, -8. Also for the Y, -8. Now see if there's one for X. I'm sure there could be, but it's been working fine. Position in stop, -8 as well. Those need to match, at least for this setup. Okay. Speed X. No. Hold on, let me check one more thing. Remember, there was a 7. Position. I also did have to increase my max position. That was set at like 225, which was obviously not correct. So took that up to 235, and now it clears all the way over to the end. So if it's not making it all the way into the little probe catch over here, that is where your issue lies on that one. Okay. Gotta quit hitting save. Didn't have anything in sensors, I don't believe. Nope. That's for future use. Nothing in steppers. That's for future use. Well, we actually have TMC steppers. It had to be in here. For our Z probe offset, the one problem I had with that as well, I'm sure there's an option. I should go back and look at the macros. Because once again, this is not on there at the point that once you issue the probe calibrate for setting the Z offset, that threw an error. So what I did was actually heat it up, put a piece of paper on there, drop it down to 1 millimeter, then take it 0.1 down to 0.1, or until I felt it hit. As soon as I felt it hit, I checked what it was at, and I either added or subtracted that number from what was in here. And it took 4 or 5 times. We ended up with 3.350. I'll show you the results. That actually worked really well. But I'm sure there's got to be a way to get the probe calibrate script to work. Or G-code macro. Those were all standard. Standard lift speed was standard. And mesh. Yeah, that's the one I changed for the up. It's not fade start. Wow. I have completely lost it. Sample retract, lift, no. Okay. Yeah, I just don't know. I have lost it. The gist of the situation, hold on. Horizontal move Z can't be less than probe Z's offset. Look at that. I left the tab open. Yes, horizontal move Z can't be less than the probe's Z offset. So that was very important. I wouldn't ever have even thought about that. Yeah, there was the 7. You need to increase your horizontal move Z to be higher than 7.3. Yeah. So that had to be higher than my offset. Which was odd, because I hadn't changed that. So I took that to 10, which did, that's right, that was all part of the same thing. So that did increase the height and resolve of that issue. Okay, but still could not get these eccentric nuts to tighten up evenly to the point that these were riding even on both sides. But before we get to that, then we had another problem. I look up. It's going to probe. Probe is gone. Magnet's still stuck. I'm like, what? So, take a look at it. Decide we're going to put some super glue on it. Didn't have any super glue, but it had Loctite. Loctite is super glue. So I put a dab in here, and because this one kept trying to pop up, maybe go back to OBS to make sure you all can see what I'm doing. There we go. So one of the two on the top, it kept trying to pop out, put some in there. Didn't work. That just ended up cracking the case. You can actually maybe see the little bit of blue, but it just split it right there. Nothing I would do would get that magnet to stay. Maybe some Elmer's glue or Gorilla Glue, but I wasn't going to go through that. So, printed another one. I'll tell you straight off, for as low cost as this modification is, for as easy as it was, even with these issues, and the fact that I could print another one, as long as you have another printer, but print one off or go back to some manual bed leveling, and in 20 minutes have another one to replace it, even if I completely destroyed the switch on the end, to me, that's a lifesaver. That right there just means never down because of a probe, because those BL Touch style probes are going to die on you. They are going to stick on you. They are going to crash and get bent on the end and then throw off your Z offset. They work fine and then they don't. And then what do? You buy a new one, unless you have another one sitting there, but you buy another one and you wait 2 days on Amazon or pay a little extra to get it the next day. Of course, it's going to be right when you need it. I really like the fact that this cost me pennies. And if you didn't have some of the spare parts, $5 the most. And that would be enough to make 2 or 3 of these so you have backups. I like that. So I printed another. It came apart easy enough. The magnets, I just took a stack of other magnets, popped them right on top, and they just came right out. Took the 2 screws out after I struggled for a little bit. And then just took a pair of needle nose pliers and just pushed on the legs of the switch, and it popped up enough that I could just pull it straight out with the needle nose without crushing the switch. And there we go. That one's going in the garbage. And then, so this one, the one caveat I could say about this is if you have a printer that is not decently calibrated, I could see having issues when you're trying to get the magnets in. Same printer, same settings, everything exactly the same. This time, the magnets fit absolutely perfect. What I think the root cause was, and this was my own bad, I even said it previously in the video, is the fact that I pulled this switch off of one of these, and there was still a little bit of solder on there. That was just enough to push those legs up, that actually there are little bitty channels back there to sit in there. So this time I did 2 things different. Number one, you're printing this with supports, so you have to pop those supports out. Luckily, as small as they are, you can just put a flathead precision screwdriver, boop, into the little hole, pop it sideways, the whole support comes out on both of those. Absolutely painless. The only place you need them. You don't need one here on the side, unless you have a really bad printer. Or in here. That would be horrible. Then, I took the same precision screwdriver, and I just cleaned and cleaned and cleaned and cleaned. I guess I should have kept the old one for that. Which is totally gone now. It's totally gone. Okay. Totally gone. Toothed it all. But basically, the hole in the recess where the magnets would sit, I just went in and cleaned up every edge around there. Just, I probably spent 5 minutes on each one of them, going 2 directions, and then the little slot right here where the legs fit in, I took this and went through that as much as I could, and then cleaned up on this side as well. Just cleaned up in there until I could get every little bit of plastic out of there that was not supposed to be there. Then, which I still recommend doing, but because this switch still had some solder on those legs, when I pulled it out, I got my trusty file, I just laid them down the side, and I ran them down until they were nice and smooth. If you do have a problem where you end up bending one of these legs in the process of trying to put this back together, and then even with pliers and squishing that leg flat, you're still having a problem with these magnets just wanting to pop right out, this might be your solution. This was 15 cents at a pawn shop. It's a good place to get tools. Yeah. So I just cleaned them up till they were silver, and then this time it fit in absolutely perfect. Then, the next thing is because I did previously have just a little bit of those legs sticking up at the magnets. Took my same file and just filed it down. Only took like 30 seconds. Like, you're right. Scuffed up my magnets, and it got them perfectly smooth. It sits so much better now. So there is your solution for getting this top edge and the other one, if you really need to, absolutely clean. It does not have to be a file this big. This is just what I have. I would recommend using the fine side, not the coarse side. Okay, so then now we have a new probe. We're ready to go again. Except we still cannot get these eccentric nuts to tighten up correctly, or to the point that both of these outer wheels are right in even. So I rebuilt the printer. I took it nearly completely apart. I tried several times of loosening this top, just the camera so you can see, this top crossbar. Go. Adjusting this top crossbar, trying to push outwards and inwards while raising the X carriage up and down into several locations to see if is it bowing in, is it bowing out, is it tighter at the bottom, it gets tight up here and it's loose at the, yeah, which one is it? Didn't make a difference. But I did notice that these guys were a little twisted. So after struggling with that several times, we said, hey, we're taking it apart. Once you've built one of these once, you can pretty much disassemble this whole printer in about 20 minutes. If you're smart, you will move your spool holder over a little more so you can get in here, but basically took these two bolts out, laid this off to the side, pulled this carriage, disconnected all the wires, of course, while it's off, pulled it up, pulled it right off the top, set it off to the side behind it, and took the two bolts here holding the power supply on and the line that connects them. This one with the yellow connector, which y'all can't see, but y'all know what I'm talking about, red and black wires that jumps across. Pulled that guy right off. Didn't want to, but you have to for the next step. Did not remove the Z motor. Left the Z motor attached to this piece of frame. Then I flipped this guy upside down, and I went ahead and removed, camera back down here, y'all can see, the two bolts underneath that hold these vertical Z-beams up. So there's two bolts under here, two bolts over here. I'm sure if you bought the printer new and put it together, you know what I'm talking about. I went ahead and loosened up the 4 bolts on the side, on each side of the legs, and also the 4 bolts here underneath the Y-axis, because I could just visually tell that this guy was a little bit off. It hasn't been enough to bother me. I haven't printed anything important, but that's something that the original owner, when they built this printer, just didn't notice. I really wish Creality would include like a printed little angle square guide that you could clip on there that would help you align that, because I've seen that on both the Ender 3s that I have. They both had that issue. So loosened everything up. And then the first thing we did, we're actually going to cut this guy off. So we lay it on the bottom. Clipper's going to be mad at me. Okay. Cut off so it don't make some noise. All right. So the first thing we did was I wanted to get these extrusions parallel with this bottom one. So what I did is I took my square, laid it right across in there, and I tightened these 4 bolts up in a diagonal pattern. And then I went and did the same thing to the bottom down here. So now I know that these legs are perfectly in line with this extrusion going across. Then, once I knew that was good, I barely hand loosened these guys up. I took the square, which I don't have enough room here. There. Remember, at this point, the whole top is off of the printer. Let's go ahead and do that. So I actually just flipped the printer upside down on the heat bed on the desk, and that worked absolutely fine. Then I took it and put it in here on the back. And kept this square, barely loosened these 4 guys up, and then retightened them back down. So now I know this is square to here and to here. I did the same thing. So much easier when it was upside down. This side. Got it square to this frame in here. Tightened it down. Then, now that I knew that was good, came back to the top. Actually, no, I did it while it was still upside down because you have to be able to get to the screws. And then I used my square. Oh, it was on this side. In here. I can't get it in here with all this other stuff in the way. But in here to make sure we were square between here and here. So now this Y extrusion is perfectly square with the X crossbeam. So now this whole base we know is perfectly square, and it was not. Even when I got this thing, one leg was kind of kicked and it would just kind of rock on the table. And I just loosened it and let it settle itself and tightened it down. Didn't think the printer was this bad. Unfortunately, for the next step, did require removing the Z and stop, but we weren't using it. I wanted to just leave it there for now until I knew this was working. I know it's working now, but so remember that if you are going to do this, you're going to have to readjust your Z. Or if you do this right the first time when you build the printer, you will never have to do this again, especially if you really crank these bolts down. Then we came through and we needed to get these Z extrusions. So I can get a better camera shot. These Z extrusions. Actually, I make this easier. No point to just be looking at Clipper. Sorry about that. Needed to get these Z extrusions lined up. So what I did was, while it was on its side, I had to lay it on this side and then back to this side. At this point, this guy's not back on here. So all this is off. These guys are off. Power supply is off. This is off. Get the bolts in there loosely. Take our straight edge, put it along this side because this is in here. Tightened it down slightly. Then the next step, went to this side. Put it flush against this one. This is why I had to remove this end stop to get the clearance. And then tightened it down. Tried to check on both edges and got it as close as I could. You cannot guarantee these cuts are going to be perfect. And I was actually considering I might have to flip one of these pieces of extrusion if possibly one of them was bent, which does happen. And I was not looking forward to taking off the Z motor, but got lucky. So I know it is perfectly square here, to the frame here, and square here. So this guy was good. Then went to the same thing on this side. Unfortunately, the only place to do that is right here. So you have to, that's why we took off power supply. It's just 2 bolts. Takes 2 seconds. Did the same thing, laid it along the side, snugged the bolts down just barely, then came to the back, made sure it was square, going at least this way, tightened them down. Unfortunately, with a square like this, I had a thick one and I can't find it. If you do have a thick one that has the flat edge on both sides, I do recommend that. That will make it much easier to get these Z-beams perfectly square. The best I could do with putting this here is just try to make it as flush as possible. But it's pretty square now. And then put the power supply back on. We connected it. We picked up the X assembly, dropped it, fed it back down on there, reattached our cables here on the back. Look, that's one thing nice about the Creality is they're all in one spot. Went ahead and pushed our Z wire down out of the way. And then put this top bar back on. It's highly complicated. that back in there. Get this out of the way. And of course, we are going to need the power again. Get a power strip on the bench. Okay. And then when I was going to put this top crossbar back on, I made a point to bring the X assembly all the way up to about in here. And then I tightened it down. And actually, it fought me a little bit. So obviously, pieces of this guy are just a little bit tweaked and bent. But now, then I went through, taking my wrench, and I readjusted the eccentric nuts. I did both of them. Got them very close where they would still spin quite a bit. And then I tightened this one down just enough, confirmed these wheels weren't spinning free. Both of them are touching perfectly now. I mean, if I really want to spin them, I can spin them with my finger. That's because you don't want these too tight. Then you're just up eating the wheels and binding up the printer. And then I went and adjusted this eccentric nut. Same thing. Now, both of these wheels and both of these wheels are riding perfectly in there. These are not over tightened. And as you can see, there's almost no sag now. That was way more work than I wanted to do. Was way more work. So I highly recommend, before you ever even decide to attempt Clicky Probe or the KlackEnder or any of these style, or even any of the modifications that are going to improve your printer, make sure the frame's good. Really make sure the frame's good. So put that back together, probably about 10 minutes before I restarted recording this video, and had to readjust the Z offset. Of course, this is fitting a little different now. Wasn't by much. Did the whole paper method, and we just did a first test print before I started recording. Man, I do not miss these loud steppers. So let's take a look at it and see how it came out. Now this is Ender Pro. The board has been replaced from the stock 1.15 or 1.14. Can't remember which one was in here, with a 4.2.2 that I believe that came out of one of the others, either the other Ender Pro or actually I think that was in the other Ender Pro, which got moved over to Ender 5 and then came from Ender 5 over to this guy. Yeah, so that's been put in there. It's running Clipper, as we've talked about. We have the silicone spacers instead of the springs. And now we have the KlackEnder. And those are all the modifications that have been done to this. Stock hot end, stock fan, that's it. So we printed a calibration cube. There it is. Let's look at it under the microscope. I'm glad at least this works now. I can tell I need to tune the flow of the extruder a little bit, but look at this. Oh, we did resonance testing and calibration on this guy. So we did hook up an ADXL with a Raspberry 2040 and roughly tune it once. I'm sure I'm probably going to have to do it again now that I've just completely redone the frame. So there is pretty much zero ghosting on the X. It looks amazing. Here's the Y. Absolutely amazing. This was with a generic profile. Didn't even take the time to pop open for this specific filament. So this is the Q-beam PLA. I think actually it says, ooh, 180 to 210. I think I printed this at 215. But as you can see, absolutely perfect. Let's take a look at the Z. Actually, make it a Z. Looks absolutely beautiful. Probably one of the cleanest I've seen looking under the microscope. Then here's the bottom, where we did have one little piece of goo already on the heat bed. There is our first layer. That is absolutely wonderful in my book. Too happy about that little spot, but I also know with this glass heat bed, I do have a bunch of glue stick on there, because that guy would not stick for nothing. Wasn't sure how I was going to feel about having this nice glass bed. So yeah, okay. Ender 3 Pro with clipper and the tuning, of course. Now, I think part of that has to do with, let's go back over to the browser, which is why I left this open. Let's close that. Let's reconnect. Did I not turn you on? Nope, there we go. And we're not on. I love how there's just enough power to at least let me do that. I wouldn't believe the amount of times I've said here, like, why does it just keep arrowing out every time I heat it up? Oh, it's not on. Alright, so after a little bit of tweaking back and forth, there you are going to still run into the issue on the Ender 3 is because you do have a little bit of sag on this side no matter what, that this side of the bed is always going to show higher, so you kind of have to skew it a little, which didn't take long. I probably only did about 4 height maps and did not save one, so let's go ahead and do one real quick. Hopefully our Z isn't too high up. We're going to home. I like how it just taps and goes back. I don't know why, but that's... I feel like I'm watching Pong. And quite honestly, the results I'm seeing with the KlackEnder, the repeatability and the multiple measurements that it's taking at each coordinate as it's going through and measuring are exactly the same from the first and second time. First and second. Every time they're exactly the same. None of my BL Touch style probes are that accurate, and in between two of them I can see a ton of difference, and every time they probe they come back with a slightly different reading. That's why I think this is really going back to where we started. It works so well. So now that we've homed it, let's go ahead and auto bed mesh and Z tilt Z29. Did had to comment out Z tilt. Yep, nothing special there. All right, so let's do the bed mesh. If I even get the camera in here somewhere. It is decently fast. What I want to do browser. Look at the results in here. You will notice for each point, they are exactly the same. Or so close. Oh, I do see like a 250 variance in one of them. Talking 0.01 amount of difference. That was a little, it was about the same. Just That is the cleanest probing I have seen out of any of the bed leveling probes that I have used. I am seriously impressed. It's very strange. We're going 360 back to where we pretty much started back in the day. But wow, it's so simple. It's so cheap. It works so good. I didn't have to come up with a fancy mount. I do know, as long as I don't change out this carriage, it's going to work with pretty much any hot end or assembly that I can stick on there. There we go. Just beautiful. Okay, so now let's get this guy back over here. We will come into the height map. And there's what we got. You can tell I still got a little more tweaking to do. So over here in this corner, I'm not sure what this hump is, but it is pretty even across. But if you look at that, is a negative 0.15 to 0.09 on the high. Okay, unscale the map. Yeah, boy, that looks horrible unscaled. So probably about 20, 30, 40 minutes of readjusting my bed screws to get that perfectly dead on. But that is super impressive. For the amount that is varying, I don't think you're ever going to see that. Yeah. Super impressed. And I should save this one. Still on the fence if I'm going to run this every time. But from what I'm seeing, may not need to. I know a lot of the Voron guys don't do a bed mesh every print. Of course, they have a bed that doesn't move. But yeah. So let's come back over to OBS. Fortunately, I can't go back to the main camera. So we will just stay on this one. So there you have it, guys. The KlackEnder. Way more work than I was expecting. But I am super impressed. I am super happy. I'm wondering how long it will last. I do like the fact it's nowhere near the hot end. It extends far enough that you don't have to worry about getting your nozzle hot to make sure you don't have a glob on the end that's going to screw up your measurements. I like it doesn't live near the hot end. I do kind of wish there was a third magnet to kind of hold it a little more in place where it is. I don't think it's ever going to fall off, but it works so well. It works so well. So I have to give it up to Frank, aka Sam, or Sam, aka Frank. I think it's Frank's. Let's make sure we get this right. Sorry, Kevin, aka Sam. Boy, got that totally off. Kevin, aka Sam. This is an excellent design. It was a little confusing, of course, because it's on Thingiverse Things, printables. I originally saw the version that still has the version 1 that has a large, very different mount, and of course the YouTube video is still on that one. This is a much cleaner design. I like it. I like it a lot. Yeah, I can't see any real improvements I could think of, except possibly, like I said, a third magnet. But I think this is going to be fine. I did see from ModBot, if you are having trouble here getting this guy to catch on there, it was either ModBot or Kevin, aka Sam, recommended angling this actual mount. You can tell I have it slightly down right now. Slightly up before, it just seems to be catching better like that. But I think it's going to be fine. Looks a little funny. Sounds weird. Takes a little bit to get used to. I'm going to experiment with speeding up the actual bed mesh to see if I can get that up faster. The fact that I'm seeing such repeatability results with such a simple auto bed leveling sensor is highly impressive to me. and makes me slightly angry with all the money and time that I have spent over the last several years with all those others. Excellent design. Excellent design. You thought of everything, I believe. I can't see any situation that this is not going to work. Yeah, until you change out this carriage, but excellent, excellent design. Props to you, sir. I am probably going to put this on several of my other printers. I'm already considering printing one of these out with a slight modification to throw on the Ender 5, because I am that impressed with it. Even though we just threw a 3D touch sensor on that one, this is looking so much better, and I will probably wait on my other 2 printers till those sensors die, and then we are definitely going to this. It's just worth it. So I will catch you guys next time. Yeah, so if this helped you out, leave a like. If not, write a snarky comment. I might read it. I might like the comment. I like things like that. Check out his repo. It is on GitHub. If you just Google KlackEnder, this is definitely come up. I definitely recommend checking out Modbot's video. I will say that you're probably going to spend a little more time in the configuration than you saw me do, or you see Modbot do, or even Kevin, aka Sam, in his video. I did have a few more things I had to change, and I see there's a couple other versions that people out there have, so stick with the original. At the worst, you're just commenting out the Z tilt because we don't have 2 Z's. Did seem kind of odd since this was originally designed around Ender 3 to have that in there, but that's okay. A little bit of note in there about that Z height movement setting I had to change. Probably be important. And besides that, that was really it. Besides fixing the frame that was just bad. So yeah, guys, straighten your frames. Straighten your frames. I will catch y'all next time. I've got some cool ideas coming up, I think. And yeah. Leave a like, share with your friends, burn it all down. Catch you on the next one. Press that like button. See you next time, Printbirds.